Hello everyone, welcome back to my YouTube channel. Today we'll be looking at another problem from the Blind 75 list of problems called valid anagram. In this problem we are given two input strings S and T and we are supposed to tell if they are both anagrams of each other or not. So an anagram is formed when the letters of a word are rearranged in some fashion. So for example we have this word anagram and the second word Nagaram. They are both anagrams of each other as this word is found by rearranging the letters of this word. We can also verify this by counting the frequency of each letters in the word. So this is the frequency. A is occurring 3 times and N, G, R and M are occurring once. And same for this, the frequency is the same. So as these both frequencies are the same, and we can also say that the count of each letter is the same. That means these two strings are anagrams. Now for the second example, rat and car, this is not true as there is T in this string, but no T in this string. So C and T are distinct in both of these strings. So these both are not anagrams. Okay. Now how can we solve this problem? What could be the most straightforward solution? Well, what if we sort the strings and just compare to see if the resultant strings are same or not? Will that tell us if both of them are anagrams or not? Yes, it will. So for example, consider this case. We have two strings, anagram and nagaram, and we sort both of these. The resultant string is AAA GMNR, and same in this case, AAA GMNR. And we now compare that if both of these are equal or not. Yes, they are equal, because that means this string, these original both of these strings are anagram of each other. Now, what would be the time complexity of such an approach? As we are sorting the strings, and sorting we know takes O of n log n time. So time complexity V of O will be O of n log n. And what would be the space complexity of of this approach? The space complexity will be O of 1 because we are not using any extra space and only sorting the input strings directly. In this, we have not included a space required for sorting. This can differ based on the language. Now, can we reduce this time complexity to something like O of n? What if we can somehow store this original table that we created? Just calculate the table for both and compare if they are equal or not. Yes, we can store the frequencies of the letters in a vector or an array and use that array to say that if both of them are anagrams or not. So let's look at that approach. Okay. So first of all, we are given two strings S and T. Now we check the length of both the strings first. So if S and T are different in length, so S dot length is equal to T dot length, only then we proceed. Because we know that if the length is not same, then both of them cannot be anagrams of each other. So that is done. Now what we do is we create a count array. A count array initialized with 0 at each place of size 26. Now why are we using 26 size array only? Because in the question we are given that the strings contain only lowercase English letters. And lowercase English letters are from A to Z. So that means we will only require 26 places to store the frequency of the letters. Now, what we can do is map the indices of the array. So 0th index we'll use to store the frequency of A. First index we will use to store the frequency of B, and same for every letter. So 25th index we'll use to store the frequency of letter Z. Now what we do is go from left to right in this first word, which is anagram, and store the frequencies of each letter in this array. So what we do is in this count array, I take the letter which we are in which we are currently at. So let's say we are at A, and we subtract it with the letter A. So what this will do is convert the letter to its particular index. So this is the conversion which we are doing. Conversion of the letter to the index, and we just increment the value at that place. So what will happen is, first we'll increment A to 1, N to 1, A to 2, G to 1, R to 1, A to 3, and M to 1. And this will result in this array. Now this is the count of the letters in the word anagram. Now we need to compare it with the second word, nagaram. So to compare it, what I am doing is just reducing these frequencies one by one. So when we go from left to right in the second word, instead of incrementing, I'll just decrement. And when decrementing, if any time the frequency becomes less than 0, that means there was one extra letter in this word which this first word didn't have. So that means these are not anagrams, and we return false directly. But if we are successful in doing so without returning false, then we return true and say that both of these are anagrams, because at the end this whole array will become 0. So that means both of the input strings are anagrams of each other. I hope you got that, but it will become more clear once we code it out. Now, what would be the time complexity of this? As we are visiting both the strings once, so that means it would be O of n time complexity. And what would be the space complexity? As we are storing only the frequencies of each letter, so we are using 26 spaces, so it will be O of 26, which is O of 1. Now let's see how we will solve this in code. So we are given a function isAnagram which takes the input strings s and t, and it's supposed to return bool, which is true or false if the both of these strings s and t are anagrams of each other or not. So let's start by creating the count array which we initially discussed. So this will be a vector of type int. Let's name it count. Size will be 26, and initially we'll put 0 in each of the index. Now we will move to each character in string s, and we'll increase the frequency of each character by 1 to store the count. And once we have the counts, we'll do the same for the second string as well. But now this time we'll, instead of increasing this, we'll decrease the counts. Sorry, this should be C because C will be the current character. Okay. And now if this count becomes less than 0, so this becomes less than 0, in that case we just return false, otherwise we return true. And I forgot to add the first condition that we discussed, that is if s dot length is not equal to t dot length, in that case we just return false directly. Okay. So first we are comparing the length of both the strings. If they are not equal, return false, they can't be anagrams. Create a count array of 26 size, because the input letters are all English letters, so we need only 26. And store the counts for array for string s. Then for string t, decrease the count, and if any time count becomes less than 0, we return false. Otherwise we return true because they will be anagrams. Let's try running this. Okay, both of the cases worked as expected. Now let's try submitting it. Okay, so you can see this approach worked. I hope you liked this video. Do like, share and subscribe. Until then, happy coding.